We are continuing on with our work with equations and solving certain equations. Today, we're going to take a little look at word problems. All right. So what I need from you as you're following along is to make sure you have down these word problems. So you have an example to kind of base your work off of when you get to the ALEKS assignment. And these word problems are going to be a little bit different with our equations. It's going to be a little bit easier of a process to solve, but we are going to involve fractions while solving these equations, all right? So there's one real rule or tool that we're going to use as a resource to help us solve once we set up the equation, but that's part of the problem. Right now, I have everything written in words, right? I don't have an equation set up yet. I need to take out all the important information from this problem, set up an equation and solve. And like I said, the equation itself will be a one-step process, but we need to get to that point first, all right? So take a second here, jot down this word problem, and then we'll get started with the first example. It says a club had a meeting with 24 people. This is only 2/3 of the club's total members. How many people are actually in the club? So it's a club for whatever, 24 people showed up, but everybody there understands that that's only 2/3 of the people that are in the club from the beginning, right? So we're trying to figure out, well, how many total people should have been there if 24 only showed up, okay? The way that we're gonna do this is to just try and pull out all the necessary information that we have, right? So club had a meeting of 20 people. This is only 2/3 of the club's total members. Saying how many people are in the club in general. Well, whatever they're asking you to find, all right, we're gonna associate a variable with that. So every time that you have a problem like this, you're going to ask yourself, what are they asking me to find? And then I'm going to make sure that I make that my variable that I'm going to solve for, right? Because that's what we do in equations. So in this particular example, it says, how many people are in the club? Well, I'm going to make X my variable. What I'm going to say is X is equal to the total amount of people in this club. So I know specifically what I am solving for. All right. If only 2/3 of the members are there, well, then what operation do you think needs to take place? You either have addition, subtraction, multiplication, or division. What operation do you think needs to take place between 2/3 and my unknown variable X if I'm trying to find the total amount that's there? So there's 4 operations. I have X, which is the total number of people, and then 2/3 of that. What do you think is going to go on between the 2/3 and the X? Am I going to add those together to find the total? Am I going to subtract them? Am I going to multiply them or divide them? It's okay to be wrong. Multiply. Good. The reason I multiply, it's the same thing as any kind of proportion or anything like that. So take the amount of people in this class. Say there are 20 people in the class, right? And half of them are girls. How many people do you have that are girls out of 20? 10. What'd you do with the 1/2 and the 20? Right, well, you multiply them together, right? So you said 1/2 of 20 is 10. So you multiplied the 20 and the 1/2, right? It's the same thing that we're doing here. We have 24 total people that are there. We're trying to find how many people are supposed to be in the club in general. So I'm going to take the 2/3 and the X and multiply them together. So that's always going to be your first step. A lot of times in these word problems, you're going to take whatever fraction they give you and multiply it by your unknown. And then you're going to set that equal to the value that you do know. If 24 people are there, and I know that that's 2/3, well, then 2/3 times the total amount is 24, right? So I've taken something that is a word problem, and now I've created an equation for myself to help me solve for my unknown variable. Does anybody have any questions about that idea? Everybody follow along with that? Everybody good? So now the only thing, question.
I was gonna add something.
Yeah,
I
sure.
didn't know if you were gonna mention the already, or kind of give them a hint.
Oh, yeah. So that's another, yeah, you can, yeah, that's fine.
So just to help you guys out too, the word of there is that lets you know too that it's gonna be multiplication. So, when you see those in there, it's that, the of.
So this portion here in any word problem, so 2/3 of the club's total members, that gives you an idea of, well, I'm multiplying the 2/3 by whatever my unknown is, which is the total members. All right. And we're going to see that again in the next example. So somebody would probably be able to point out in the next one what operation is taking place in between which two values. All right. Now, the only thing that's different here with solving, a way that I get rid of this fraction. Does anybody know how I get x by itself here? What can I multiply both sides by? If I want to get rid of a fraction and get that variable by itself. Does anybody remember that term reciprocal? What's that? Nah. So if I have, all right, so I'll give you a different example, right? If I have 4/5, the reciprocal is 5/4. So what did I do? Just flip them, right? So a reciprocal is what I'm going to do is I'm going to multiply both sides by whatever the opposite of this fraction is. So instead of 2/3, what am I going to multiply both sides by? 3/2. Because what that does, the reason that we're going to do that, all right, this 2 and this 2, what's going to happen with the 2's? They're going to cancel. What happens with the 3's? And what's left over? Well, hold on just on this side. Well, just the x. Whatever I do to one side, I have to do to the other. So I'm going to multiply 24 by 3/2 as well. And using a calculator or doing some mental math, what's 24 times 3/2? You can do 24 times 3 and then divide it by 2. Or you can do 24 divided by 2 and then multiply that by 3. What's that? 36. Good. What did x stand for in the beginning? What did we say that was in place of? Like, what does that represent? Total people in the club, right? So 24 people showed up. That was 2/3 of the people. So the total amount is actually 36. That should have been there, right? If you had perfect attendance. So that's how you would solve that particular equation. All right. But notice that we started, question. 24 was what they gave us. So they said 24 people were there, right? So I just set that equal to whatever value they give you. And we're going to see in the next example, it's going to be very similar. So whatever value they do give you, that's not the fractions, pretty much what you're going to set it equal to. All right. Question? So it depends on the situation. A lot of times it's just going to be a whole number. Depends on what you're talking about, though. Like, obviously, you're not going to have a fraction if you're talking about number of people. Can't have like half a person, right? No. You just leave it as a whole number. Good question, though. Any other questions about that first example? Second example, you want to go to a game. Speaking of which, Phillies, Eagles, and Sixers are 100% capacity in June. Nah, 100%. So that's pretty cool, right? So everybody can go. There's no like restriction on people attending anymore. Yeah. So you go, maybe you want to go to one of those games, all right? And you're saving up $25 so far for a ticket, all right? But as you're trying to reach your goal, you realize this is only half of the total price. Okay. So they want us to find, well, how much is the total ticket? Again, whatever I'm being asked of, I'm going to make that my variable. So I'll say X is the total price of a ticket. Well, think about what Miss Smith said. She said, if you see the word of, right, that's a good sign that you're going to use multiplication between two different values. So what should be multiplied together here? 1/2 and what?
Send it right there. That's it. Only half of the.
Okay, so you have the answer, right? But let's try and work backwards to create an equation because it's not always going to be an easy fraction like that, right? What if it was like 3/7? Would you know off the top of your head?
Be honest.
No, exactly, which is fine, which is totally fine. But you want to create an equation to help you find that because you could solve that. All right. So it's not 1/2 and 25. It says 1/2 of the total price. Well, what do we know is the total price right now? What's in place of the total price? We don't know the total price yet, right? That's what we're trying to find. 1/2 of the total price. Well, they don't give us the total price. So it's 1/2 times X, the unknown variable, the value that we're trying to find is equal to 25. Why are you look confused? Well, okay. That's the next step. What do I have to do on both sides here? What's the reciprocal of 1/2? 2/1. So I multiply both sides by 2/1. What's 25 times 2, Isaiah? 50, right? So she had the answer ahead of time because we're dealing with easier fractions, right? But like I said to Chase, say it was 3/7 or say if it was like 2/5. Off the top of our head, we might not know that that's what that value is. So we have to create this equation to help us. So the total price of one ticket is 50, right? How about this for a little bit of a challenge? Say you save $25, but you want to buy 2 tickets. Work backwards now. So you have $25. You want to buy 2 tickets. How much is the price of 2 total tickets if one's 50? 100. So if you have $25, 1/4, good. That would be your fraction. You have 1/4 of the total price. What if one ticket was $200? Good point. That would be an eighth, right? So you're dealing with some fractions, you're dealing with different, variables involved, different prices. It might not always be an easy fraction like that. Okay. Yeah, fractions aren't everyone's friend, but it is what it is. All right. Any questions about either of those 2 examples? Anything that we covered today? Everybody good? Okay.